So if I wanted to inject water in here and prevent that water from leaking out in the sides here, I would put, first of all, I'd put a little groove right here into the table, and then I'd put an O-ring in that groove, and then I would come down and place this cup on top. And that would be a face seal. Now, let's pretend that I had something that was, like going inside of this cup. And I wanted to create a seal between my hand and this cup. Obviously, my hand's going to leak because it's a weird shape. But let's pretend my hand is, a cylinder that's a little bit smaller than this cup and it fits inside here. Then I would put an O-ring around my hand and I would place it in here. And the compression would be between this wall and the outside of my hand. And that would be a radial seal. As opposed to the face seal, which is, it's like it's on a flat surface. You're in a flat surface, and the radial seal is like between two cylinders. So here's one cylinder, my hand is the other cylinder. That's a radial seal. Does that make sense?
Almost, because in the blue here, I only see this is radial, but there's only pressure on the blue side. There's nothing pressure on the outside. So it's not like with your hand and the metal here. From my understanding, how you explain the radial is that there's pressure on both sides, inside and the outside.
Well, there is, because you have this blue metal part that's, inside the O-rings, and then you have these two O-rings. You basically slide the cup up or slide that metal part down into the cup, and so you have these two O-rings that are contacting the inner face of this cylinder. Does that make sense?
So are these two the same O-ring?
It could be.
This is in different...
Yeah, could be.
So when we're a mechanical designer, does it really matter what we call them? They're really just O-rings used for different purposes. Right?
Yeah. The distinction between a face seal and a radial seal is not in the geometry of the O-ring or the shape of the O-ring. It's in the application. It's how that O-ring is placed in your geometry.
Oh, okay. I thought that there were different, like when you went to McMaster, you would order like a radial seal O-ring or a face seal O-ring.
Got it.
That's not the case, right?
That is not the case. Yeah, it could be the exact same O-ring.
Could you explain that a little bit better, this right here?
Sure. These are cross sections. They're called cross sections. It's a very typical way of looking at something. And imagine taking this part right here, this blue metal part with the O-ring surrounding it. Imagine taking that and cutting it in half like this, and then looking at that cut half. That's what you'd see here. So like this right here, well, this would be an outer cylinder. So you could imagine this as like the cup. If we cut the cup in half that, this would be this wall section up here. This would be this wall section down here. This right here is one of the O-rings. This one has two, so it's a little bit different, but that's the cross section of the O-ring on top, and that's the cross section of the O-ring on the other side.
That's enough, I think.
Okay.
Makes sense.
If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.